Farah, you just type your ID. I will add later on lah. But I have your ID, so I just add later on lah. Okay, so today kita akan cover fourth lecture. Okay, last meeting we cover the regression analysis. So we will look into the logistic regression and regression tree analysis. So this is the extension of the normal regression analysis, in which regression analysis deals with numerical value. You need to cast numerical value or continuous value. So we will look into this logistic regression first. So there are two parts. First one is logistic regression, and the other one is regression tree, in which they model your data using trees, so that you're dealing with a different type of prediction. In the regression analysis, in the previous lecture, we are looking at forecasting continuous value based on time series. Okay? And now we are looking at logistic regression, in which we are trying to predict integral value using the probability of having that particular item or not. So let's take a look at that one. So if you recall back, the normal regression analysis, we are trying to forecast the continuous value, the dependent variable which is of type continuous value. But for the logistic regression, we are trying to develop algorithm to predict qualitative outcome, which is a type of categorical value, male versus female, purchase or not purchase, tumor is benign or versus malignant, dangerous or not dangerous. So we are looking at the finding the probability that are bound by 0 and 1. So for example, like this. Let me get the pen first. So in linear regression, we have this one. This is your dependent variable, and this is your independent variable. Also, we have the ax plus b. B is the intersection of y when your x is 0. If we look at the logistic regression, your dependent variable is between 0 and 1, meaning that you will have the probability of having, not having. And this is your y, your independent variable. This is your dependent variable. This is your independent variable. So when we look at the regression analysis, in the previous lecture, we are looking at this one as your numerical value or continuous value, because we want to predict what is y. But for the logistic regression, we use logistic regression when we have a qualitative outcome, or your dependent variable is a qualitative outcome. For example, male, female, so on. Okay. So let me proceed. If you feel confused or you don't understand, you can stop me and ask question. Okay. So here they say logistic regression is a special case of regression analysis is used to calculate when the dependent variable, so your dependent variable is y, is normally, nominally or ordinally scaled, which means they are category value. Male, female, purchase, not purchase, infected and not infected, and so on. So for that reason, we are looking at the value 0 or 1. Dichotomous variable. The variable that we have must have two outcomes only, yes or no, male and female. Okay? So we can use the logistic regression to predict whether that particular variable that we use exists or not exists. Okay, so for example, like this, we are looking at the age, gender, and smoking status. This is your independent variable. Okay, your dependent variable is whether you got the disease or not. This is if you have the disease, then this is 1. If you do not have the disease, then you will have 0. So if you compare with regression analysis, they are totally different. Okay, but we can use logistic regression for the if you want to model the nominally or ordinally scale variable, which have two outcomes, 0 or 1. So if we try to describe then in this graph, we are looking at this is your dependent variable, okay, and the rest is your independent variable. So your x value is from this range, but it turned out to be that your dependent variable only fall here, 1 or 0 only. So we cannot use this to model the data that we have. So the graph show that value between plus and minus infinity can now occur. So meaning that you can have plus and negative infinity here. So the goal of the logistic regression is to estimate the probability of occurrence. So between 0 and 1, but not the value itself, not the value of this, but we are looking at the probability of having 0 and 1. So to ensure that we get between 0 and 1, we use the logistic function or binomial function. Okay, let me show you the binomial function. So this is the logistic model. It's based on the logistic function. Okay. So value for your y will be between 0 and 1. And this is the function that they use. So the z here is basically y value or the dependent value that we are trying to estimate here. So if we replace the z with this value, so remember that when we have this value, so we could have 0 or 1 for the y. So if our y is 0, so what happened to this? The whole thing is 0, so your value will be 1. Okay. But if your y is 1, then you will have 1 with the 1 plus b minus 1. So this is equivalent to 1 plus 1 over b. If this is going maximum, so what happened to this one? Infinity, right? So 1 plus infinity. When 1 divided by 1 plus infinity, you get 0, going towards 0. Okay? So the value that you get from this formula is between 0 and 1 only. So depending on your x1, x2, xx, and so on. So we use this logistic function, okay, to ensure that the value that we get is between 0 and 1 only. Okay. Okay, now we look at the some of the example on how we can use logistic regression and what kind of data that we are dealing with. So these are the steps that we're going to go through. So data preparation, how do we clean the data? How do we handle missing value? And then how do we train them? Okay, by splitting data into train and testing, and then we do the model fitting, and then we evaluate the model, the performance of the model based on the predictive ability of the model. So these are the steps that we will go through. So first, data preparation. Let's use this data called Titanic. This is the um, data that they have consists of all the passenger. They have 891 passenger, and they have 12 variables. And we have this is your dependent variable, survive. So whether they survive or not survive. And we have all these dependent variable. So if we look at the variable that we have here, so this is between two values, 0 and 1. Okay, so whenever you have a value 0 and 1 or no, yes, or only two categories, you can use logistic regression. So how do we proceed? Okay, let's do some cleaning. Notice that we also have this NA. NA means missing value. We also have over here. So we need to clean our data first. So we have to look at the empty or the non-applicable data that we have, and then how do we deal with them. So this is the definition that we have. So this is our dependent variable, 0 and 1 only. And this, the P class refer to the ticket class, first class, second class, and so on. This is the gender, the age, have the number of sibling, spouse aboard the Titanic. This is number of parents, children aboard the Titanic. Ticket number, passenger fare, cabin number, and port where they join the ship. So we have C, Q, and S. Okay. Okay. How do we check for the missing value? Just now we are looking at this function called is.na. So we are looking at non-applicable data or missing value by using the function is. So we are looking at we try to apply all this trying to apply this function to all of the column that we have here. So the number here tell you for the column age we have 177 missing value. The cabin is 687 and embark is okay. So for the cabin, if you look at the cabin, this is the cabin number. We have to know the cabin number. For that reason, we cannot include this one because we cannot tell what is the exact cabin number. So we will remove this one. And for this one, we have two missing value for two rows. So what we can do, we can remove the rows number. And for this one, what we can do is we can get the average age, and then we can substitute the empty cell with the average value. Okay, that's how we're going to deal with this one. The second statement here is just looking at how many unique values that we have for individual column that we have. And one thing for sure is that we do not need the passenger ID and also the name, because these two has nothing to do with the prediction whether you survive or not. So we will remove the passenger ID and name. So how do we deal with the non-applicable data? So we can use this mismap function to visualize the percentage of missing data. For cabin, we have 600 over, and then the age we have 177. And also the impact we have 2. Okay, so we will remove this one. Okay, so how do we remove that one? Will not include this one. So basically, we will remove the passenger ID, which is this is 1, 2, 3, 4. So we do not have 1 here and 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we also remove the ticket here because we can tell which cabin they are, no, which parcel they are. Okay, which fare ticket. We will remove the ticket number because the ticket number is random, right? It's like your no lah, plate number. So the ticket number does not tell any information. Okay, so we remove the ticket number and also the cabin since we have a lot of missing value here. So the subset function is used to select only a selected number of features only. So we remove 1, 4, 9, and 11. So I don't have here. Okay. And for the age, we say we're going to replace with the average. So what happened is that we will get the mean average of this column where the NA is 2. Okay. No. We will not include the non-applicable as the value as the number of row that we have. So meaning that we get the average age here without counting the row that include NA. Okay, so the mean will be used to store the data in which cell that contain NA for this particular column. Okay, then we update them. And also we could check whether the some of the value is label or not. If you look at the reading here, when we say read this file and we say string as factor, meaning that all the label will stay the same. They will be factor. So for example, this is string of character, string of character, string of character, string of character, and so on. And also, yeah. So this is how we check. Okay, we also can use the contrast. Okay, we can use the contrast to get the categorical value for the male and female, also for the impact. So just to tell you, when male and female they does not match, so male and male they are match, similar to here. Okay, so CQ will not be match, and then Q and Q will be match. So this is the categorical values. Okay, and remember that there are 2 rows that we want to remove. So we will not include the row that consists NA in our data, and we only include the rest of them. So this one we remove the 2 rows that we get this column as NA. And last one is we want to remove the row names for this data because if you run this statement, you will have row number. we do not want to include the row number, the row name. So we will say, okay, for this data, the row name will be eliminated or make it null. That means there is no row number or row name. Okay. Otherwise, we will have additional column hidden that you will not see until you export them into Excel. You can see the row name 1, 2, 3 up to the number of rows that we have. Okay, now after we clean, because this is we remove the 2 rows, and then this one we are replacing all the NA, the age, the mean average. Then for this one, we just simply remove this column and the other column that have no meaning to the prediction of the survival. Okay, next we will do the model fitting, or we will train the model. So first what we need to do is we need to divide the data into training and testing. Since we know that we have 8, 9 rows, okay, so we could choose 1 to 800 rows to be the train data. Up to you, you could choose 1 to 700 only or 1 to 600 only. And the remaining, for example, 7, 1 up to 8, 9 will be assigned to test data. So notice that we have 2 parts here. We have data, then we have square, and then we have the comma, right? So this is the column ID. This is the row ID. This is the column ID. So similar to what we have in programming in C, the first variable value the row number, and the second part in the square bracket is the column number. Okay, so when we put this one empty means no column. Okay, so this is dividing your data into training and testing. Okay, now we will use the LM, okay, logistic linear model, okay, in which we take the survive. This is the dependent variable. Model using our independent variable. So this is all. The dot here refer to all, and we will use the numerical function. And the data that we have is, okay, so remember that in train you have only this class, sex, age, sibling, parent, child, and inbox. And this is your independent variable, all the independent variable. Okay, so once we call this function GLM, they will model your data and put this one as the model produce. So when we the summary, okay, the summary tell you whenever you have the 3 star, there are significant attribute that can be used to model your survival here. Okay, so the 3 star here meaning that we have very significant factor that can be used to model your data. So in this case, like the parent, child, fair, whether you embark in Q or S, they are not significant. And lastly is, okay, once we get the model here, because this is for training, remember that we have the test data set. Okay, the test data set now is used to perform the prediction. So we're looking at the model that we have produced, and we are looking at the test data set. The test data set, we only select 2, 3, 4, 5, 6, 7, 8 because we eliminate the first one. The first one is the survive, because that is your label. Okay, so we will only give you this remaining data except the first one, which is your survival column. Okay, and the type of response will be from, so we are using from 0 to 1, and the output that you get for this fitted result will be between 0 and 1. Okay, once you get the output here, so we will convert them into 0 and 1. So if the fitted result is greater than 0.5, we will assign them value 1. Otherwise, we will assign them value 0. So now we can look at the matching between the predicted value versus the actual one. So we want to know how many of them does not match. Does not match, and then we can compute them, and whatever error we have, because the error is computed using the number of mismatch. Okay, so we can get the error here. So the accuracy is around 1 minus number of error you have here. So accuracy is 1 at 4. So this is the accuracy of your model when you're using logistic regression to model data that we have. So in the future, if someone asks you, okay, can you use logistic regression perform classification or to perform prediction of 2 classes? Yes. But for multi-classes, you cannot perform. Because remember that the value of the prediction of the model is between 0 and 1. So the compute ke barang kalian untuk dapat particular item or not, 0 or 1. Okay. Okay. So any question on this? So always remember that logistic regression can be used for binary classification only. Okay, so for multi classification, you have to use different method lah. Okay. Any question?
No question.
Okay, so we will continue with this regression tree. Okay, regression tree is to model dependent variable which falls within some scale value. For example, we normally ask people to rate performance based on a scale, a predefined scale between 1 to 5, excellent 5 and poor 1, and so on. Okay, so you have this range of value, okay, 1 to 5 or 1 to 10, but you want to know why people put 3, why people put 4, 5, and so on. Okay, so what we can do is, okay, we can build a tree, something like this, and the leaf of the regression tree is the choice or the value that they have. So we have 1, 2, 3, 4, and 10, and so on. Okay, so by having this, we can tell why people put 3. So we're looking at the value of variable here, the value of variable here, that push us to left or right. And also, since they are called regression tree, So you only have two branches coming out from the attribute. So meaning that your independent variable and also your dependent variable, they both must be numerical values, okay, or continuous value. Okay? So since the idea is you want to have something like this, for example, the scale is between 1 to 10. But we want to know why people put 2 or 3 and so on. But when they try to use regression tree, they will look at the average that people put here. So you look at this diagram, the value of your dependent variable will be numerical value, and the value of your independent variable will be numerical value as well. Okay? So these are sample of application that we can use. So, but when you say when can we use this is when you have your dependent variable as numerical value and your dependent variable will be numerical value as well. Okay, so let's look at how do we work with this tree. So in classification tree, homogeneity is measured by entropy. We learn this one, which is undefined for numeric data. So contohnya untuk classification tuh we divide them into two. If we are looking at categorical value, so we are looking at y, and then no. So we want to have an attribute that split them into two groups having high purity of label. But this cannot be applied for numerical value. So what we want to do is we are looking at some statistics like the variance, standard deviation, and absolute deviation from the mean. So we want to choose the splitting in such a way that it will reduce the standard deviation. So what does the standard deviation tell you? If you have high standard deviation, what does this one means for an attribute of continuous value? You have wider range of value, right? You have minimum and you have maximum, and the difference are too big. So that's why your standard deviation is too high. But if you have mean and maximum, they are almost near to each other. So your mean will be near to your mean and max. So your standard deviation will be lower. So meaning that they want to have when you split the data into two, the standard deviation here will be very small, and the standard deviation for here will be very small. That means you manage to divide them into two parts in which they are close to each other. That particular attribute. So we say the standard deviation reduction means that try to maximize this before you split the data and after you split the data. So it depends on the number of splitting that you have. Okay, so I use the weightage here to tell you how much weightage you should multiply with the standard deviation that we have for that particular group that we have. Okay, let's take a look at some of the examples that we have. Okay, let's suppose we have original data for this particular column, and then we want to split them according to feature A and feature B. So how can we compute the standard deviation reduction based on the splitting here? So meaning that for feature A, we will split them into where value is greater than 5. You go here. This is yes, this is no. Okay. So if greater than 5, you will pick this here. If no, you go here. So this is greater than 4. So we want to know which split will give you a better one by looking at the standard, standard deviation reduction. So the standard deviation reduction here, if you look at the formula here, we are looking at the standard deviation for that particular group, and then this is the number of element for that particular group, and this is the total number of value that you get. So we will do for each partition that we have, and we sum up, and then we subtract from the original one. Okay, so let's illustrate this one. So the first one, this is the first data that we have. Then we have this 81 and 82. This is when we split using the feature A, and BT1 and BT2 is when we split them into B. Okay. Okay, so for the standard deviation reduction for A, okay, this is the formula. We're looking at the standard deviation for the T minus, okay, to compute for both of these. So this is the length of T divided by the length of AT1, because this is for first one here, divided by this. So this is the weightage of the first group times the standard deviation of the first group. The second group will be the weightage of the second group times standard deviation of the second group. So similarly, we can perform the same with the splitting here, which is this one. So this is the standard deviation for the original one. Is this one. Then minus, okay, this is the weightage for that particular group. Okay, if we look at the data that we have, this is 3. So this is basically 7 divided by the total will be 3, 3, 4, 15. So this is 15. Times the standard deviation of the BT1. Okay, the length of BT2 will be 8 divided by 15 times the standard deviation of this group. So we type the value of this. So the higher the value is better because we choose to maximize the standard deviation reduction here. So we can say that the standard deviation, the splitting using feature B is higher, better, because they have higher standard reduction, standard deviation reduction. Okay, can you follow? Okay, so that's how they decide which splitting they want to do. So basically, in a real situation, we are looking at testing the splitting here, here, here. So basically, we want to test which splitting will give us the highest standard deviation reduction. This example just show you two parts only. We compare the value of the standard deviation reduction, but in the actual computation, we are looking at all the partition the possible partition that we could have, and then we choose the best splitting in which we have the highest standard deviation reduction. Okay, now how do we apply this one in the real world situation? We are looking at the regression tree, and okay, we are looking at this data, the quality of wine. Quality of wine is range from 1 to 10, and people will have the wine tasting. Then they will put the marks between 1 and 10. And the data that we have will be, we have 5,000, almost 5,000 wine sample. And then the content of each of the wine will be represented by 11 chemical properties. The wine tester will not know about that one. What they do is they just put the marks of the taste scaling from 0 from 10, very bad to. Okay. So if you look at the data that we have, here, we have 12 variables. So we have the 11 chemical properties, and the last one is the quality. Quality is from 0 to 10. Okay, now to see the data that we have all the IV in numerical form, and also your dependent variable will be in numerical form. So the best model that we can use is we can use a regression tree to know why people put 5 or 6 or 7 and so on. Okay, so if you look at the histogram of the quality, so most people put around here. So this different people have different perception, but I guess most people put 6, 5, or 7 to say that they are neutral. Less people say bad or excellent wine. And now we are looking at how do we split the data. So again, this is up to you. So this is 1 to 3,750 rows that we allocate for the training. Then the remaining will be allocated for your testing. So we have this RPath or the regression tree in the RPath package. So we will install this one and also upload into the memory. Okay. So how do we call this one? We use this regression tree, and this is your dependent variable. Will be modeled against the dependent variable, and this is your data. Okay. Once we get the model here, so we can perform the prediction using the test data. Then later on, we can see how much or how high the correlation between the actual and also the predicted value. So very easy, we just call R here or the regression tree, and this is your dependent variable against the other, and your data is from the wine trend. Okay. And then this one will produce a model here and will show you the tree. If you look at this one, they are very confusing, but we could use the other package that can visualize the tree. Okay, so we use the regression tree plot. So this one we say, okay, we will use three decimal for the value that we have. Okay, so this is the diagram that we get, and this is the most, I think, the best value that can split, that can reduce the standard deviation reduction for these two groups. And then they use this one again to split, and then use this one again to split. So remember that they choose the best splitting by looking at the standard deviation reduction. Okay, so at the end you have here, then you can have an idea why people put 6, because the higher they are, the better taste the wine. So they say that if your wine contain alcohol less, um, if your wine does not contain alcohol, particularly if we read this one, if your wine contain alcohol more than 10.9, then you go here. Right? And if your wine consists of free sulfur dioxide more than 10.5, you go here. And if your alcohol again above 11.8, you go here. Okay, then you can see that you can say that based on this, if all of this met, then you have a better taste of wine. There is another package that you can use. This is another part on how we can visualize them. So this is a bit confusing, but this one is a greater than or equal to 10.5, you go here, and then greater than or equal to 10.5 here. So this is referring to the alcohol, and then free sulfur dioxide, and then this one is alcohol again. So this is how we get the model. And we use the model to do some adjustment on the wine, or if you want to know why people put 6 and above for better wine. But how do we evaluate how good is the model? So we want to look at the correlation between the people have score. So this is what we is the dependent. Okay, quality. The quality. Okay, want to find the correlation between the quality score that people put and also the result that we get. So the result that we get coming from here. Okay, so basically we are looking at okay, so we predict using this model, using this test, and we get this result here. So this is the predicted part. Okay, summary. Then this is the actual one. This is the predicted value. So we just use the function correlation. This is the function correlation. It will take the predicted value by the model and also the quality of wine that people manually judge or put in the score. And then the correlation is 0.53. So at least we have a model that can use as a reference. Although the correlation is in the middle, okay, but at least we have that value. So 50% of the value are correlated to the actual value predicted and also the actual value. Okay, so if we have higher one, we have a better model. So it is very interesting to use these regression trees because you can have this model, and then we can also measure how effective they um, use the model to learn your data. So I think that's all for this one. Basically, they give you an idea what is logistic regression and what is regression trees. In most courses, they only teach you to the regression analysis only. I just include this one because this is very specific. Regression analysis um, include logistic and also regression trees. So how you can apply this one depending on what type of data you have. Okay, any question?
So
Yes.
STR, right? Doesn't it form some form of bias if we split the data to A and B? Isn't it like form of bias? No.
No, because you will test for each splitting that you possibly can get. For example, like this one. So we are not doing the feature A and B only. We will do for every different value that we have. So meaning that we are looking at one here, so every one, and then two, and so on. It will take some times lah.
So this is before the training, is it? Before the training, we are doing the splitting.
Yeah, during the training.
During. Oh, okay.
Yeah, during the training, they will analyze which splitting will give you the highest standard deviation reduction.
Okay.
Okay, so which means that in this example you have 11, right? 11 chemical properties. So for each feature that they have, they will do all of them. So 11 times whatever unique value you have in that particular features.
Oh, so the training process for this is very long if there's more features.
Yes.
And the growth rate is like more than exponential, is it?
Yes.
If there's more
So if you have
variables.
more unique values or if you have more features,
Feature.
then you have number of features times no, yeah,
Power, right? To the power.
yeah. Number
Then methods.
number of uniques. Uh, you get number of unique value for each features. The summation of number of unique feature that you have for each feature that you have. So if you have 11 features, that means for each features, you take the number of unique value you have there, you perform all. So let's say, suppose n times m plus m, which is the m times of the number of features that you have. It will let longer time lah.
There are newer approaches to this method which is less computational?
No, because now the computing power is getting more powerful, kan?
Better. Okay. I see.
Yeah, so
Interesting.
we have better RAM, better machine. So
There's no optimization for this approach.
no.
It's brute force. I see. Is it? Okay. Okay. That's all.
Okay. Rest. Okay. So very interesting this one. So for this one, you only have to understand really well how we perform the standard deviation reduction, and for this one, logistic regression is since they are using the binomial function, then it depends on the formula that we have here. This is just to give you an understanding lah, why you use the binomial function, because the range is from 0 to 1. let me